So if you've been using MCP for a while, you probably see a number of the benefits that it provides, but also might have run into some of the challenges in its current state. In this video, I'm going to be talking about one of those challenges, how I solved for it in the CCAPI or Cloud Control API MCP server, and created a new pattern in the process. I'm Kevon Mayers and I'm a solutions architect. Let's hop right into it. So first, let's recap what MCP or Model Context Protocol is. It is as it sounds. It's a protocol or a standard to help bridge the gap between genai applications and target data sources. Now, while this protocol does have a number of benefits and provides a lot of flexibility and choice, there are actually some challenges that can arise from that choice, especially when you're dealing with MCP servers and the tools within them, and you need to enforce the order in which an LLM or AI agent uses those tools. When you think of MCP, you likely think of choice, and arguably one of the main reasons you might want to use an MCP server is because that choice is a benefit to you, right? You might want to allow an LLM through agents to interact with a variety of different target data sources. So things like databases, maybe having the ability to send emails, update values, all these kind of things that you want to have flexibility in allowing the LLM to be able to do. The challenge is, well, how do you enforce the order in which an LLM or AI agent uses the tools within an MCP server? And the problem is that the MCP framework in its current state doesn't actually have a native way to enforce this. So let's take, for example, two tools, fetch weather data and send email. Now it's logical to assume that I want to fetch the weather data and then I want to send an email that includes that weather data. So something like, hi Kevon, it looks like it's going to be rainy today. Make sure you bring an umbrella. By the way, here are some things to do in your local city. The inherent nature of how MCP works in relation to server tools and how an LLM uses those tools leaves some room for improvement, and some challenges can arise in this direct process of this use case. MCP tools are designed to be unique functions that an LLM can invoke as needed. Now this means that an LLM or an AI agent can use these tools in any order that it determines to be necessary, regardless of the logical flow that you intend. Now, for some use cases, that's not a problem. Let's draw parallels from a real-world example. Imagine that you want to add on an addition to your house and you hire a contractor. Well, the contractor knows the end goal, right? You want to add on that addition, and they have access to a variety of tools, and they can choose which tools they need to use at whatever point in the job until they ultimately solve your request of building on that addition, right? This is largely what's happening with MCP, right? You have a prompt, that's a request. The MCP server tools are available to an LLM or an AI agent, and they have the autonomy to choose which tools they want to use or which tools they need to use to solve the initial query. Generally, this is what you'd want. You don't want to have to tell an LLM exactly which specific MCP server tools it needs to use in what order, any more than you want to have to tell the contractor the order of the tools that they need to use to build on that addition to your house. But what if the MCP server managed infrastructure? Now, before we get into the solution, let's recap the MCP lifecycle. MCP defines a structured lifecycle for client-server connections. It ensures a proper capability negotiation and state management. There's really three main phases: initialization, operation, and shutdown. The initialization phase is key to this solution that we're going to talk about today. And it's really the phase where an LLM or an AI agent becomes aware of the MCP server tools, what they do, and how they should be used. Now, if an AI agent has the flexibility to choose the MCP server tools it wants to use to solve the query, how do you solve the challenge of enforcing the order? Let's talk about the potential solutions. So the first solution is prompt or context loading, and it works very similarly to the way that you would add this for the AI agent itself. So within the MCP server configuration, you effectively give detailed description about what the MCP server is used for, the manner in which it should be used, things along those lines. And during the initialization phase, the AI agent becomes aware of this during the discovery, right? It learns about what the MCP server is, the tools that are available, how to use them, etc. So let's take, for example, this context, right? We're giving information. This is the CCAPI MCP server. These are the different operations that it provides, the CRUD operations. We're giving structured information about these are the order in which the tools that have to be used. And it seems pretty comprehensive, right? The challenge is this is effectively a strong suggestion to an LLM. An AI agent or an LLM can basically say, no, I don't think I'm going to do that. Ultimately, it's up to the AI agent or LLM to decide whether to use the instructions and which portions of the instructions take more weight than others. And this is why the composition and structure of the instructions really have a tremendous amount of impact to the success. So if option 1 isn't enough, what else can we do? So option 2 is a new pattern that I designed, token-based tool orchestration. Like I mentioned earlier, a main challenge with MCP is that there's no concept of ordering for these MCP server tools, even with prompt or context loading. I ran into this challenge when working on the CCAPI MCP server. Even with very detailed instructions with prompt and context loading saying, this is the specific order you should follow, don't deviate under any circumstance, it would still deviate, right? I would then ask the LLM or AI agent, hey, why didn't you follow the instructions? And it would say, oh, I'm so sorry, you're right. I should have followed those instructions. For some reason I didn't. I promise I'll always remember going forward. And it works for a little bit, but then of course, when the context window is exceeded and it needs to be flushed, now all that instructions and all that context is gone. Or same thing happens if you start a new session, right? It doesn't remember that it's supposed to actually follow the instructions, and the cycle can repeat and repeat and repeat and repeat. So with this new pattern of token-based tool orchestration, the AI agent effectively becomes a token messenger. As the AI agent is using MCP server tools, the MCP server is creating and managing tokens. And these tokens are for the specific tools that I want to enforce the ordering of. So as tokens are created, they're stored in the AI agent's context, which it then uses for the tools that require those tokens. This creates an implicit dependency that enforces the order in which an AI agent has to use the specific tools. Earlier, I mentioned the init phase of the MCP lifecycle. So essentially for this MCP server, when initializing, the AI agent becomes aware of all of these token dependencies. So it'll see that a token is generated in tool A that is required as an input parameter for tool B. So essentially during initialization, it's creating a dependency tree and storing it in context. And if for some reason it tried to deviate from the dependency tree, the MCP server tools raises errors that guide the LLM or AI agent to correct itself. So you might be thinking, well, couldn't an AI agent just fake a token? And the answer is no. It's not shown in the diagram, but these tokens are actually stored in memory temporarily, and they're used for validation. So that means when an AI agent tries to use a tool and it needs that token and it pulls it from context and passes it to that tool, it's validated against the actual token that's stored in memory. And if they don't match, it fails and the MCP server tool can't be used by the AI agent. So that's enough about theory. Let's hop over and see it in action. All right, so let's go ahead and see this in action, right? Let's see this token-based workflow orchestration. So what I'm gonna do, I'm in VS Code, but again, you could really be using anything. I'm gonna be using Amazon Q Developer for this demo. So I'm gonna start a session by doing Q chat. And it's going to initialize the MCP servers. It can take a little bit of time the first time to load. To check the status inside of Q, you just run /MCP. I think this one takes around usually like 15 seconds to load. So we're going to give this a little bit more time, maybe a couple more seconds. And yeah, about 15 seconds it loaded. Cool. So what we're going to do, let's try to actually create some infrastructure and see what will happen, and we'll explain the token workflow that's being generated. So I'm going to say create an S3 bucket with a new KMS key, and let's see what this does. All right, so the first thing that it's going to do is to check the environment variables. So as you can see, no token is actually being passed in as an argument because this is the first tool that's being used. Effectively, we want to check these environment variables that we've defined because it has really important information that configures the MCP server or the way that it's used, right? So the AWS credentials to use, in this case, an AWS profile. Do we want default tagging enabled or security scanning enabled? So that's what it's going to be doing first. So I'm going to just go ahead and do trust. You can do yes, no, or trust. Yes will approve it one time, no will deny it one time, and trust will approve it for every subsequent operation in the current session. So I'm just going to trust that in case it needs to use it again for some reason. Next thing that it's going to do is to get the AWS session info. So using the fact that we have this AWS profile, it's going to be validating that we have AWS credentials configured properly. Now, what you can see here is there's this token that was generated. So the previous tool, check environment variable, it actually generated a token that's now used as an input parameter for get AWS session info. So like I mentioned, this is creating an implicit dependency where the AI agent knows, okay, I called check environment variable. Next thing I need to do is the get AWS session info, because this one has a explicit input that's requiring this environment token that was generated. So token generated in tool A is being used in tool B. So I'm going to do, I'll just do trust to get the AWS session info in case it needs to do it again for something else later. It's going to output the session information. So I'm using standard profile. Now it's going to try to use the generate infrastructure code for the KMS key. And then you can see what it actually has here is a credentials token. So since it fetched the valid AWS session info, that tool generated a credentials token that's being passed in. The next thing that we're going to do is we're going to go ahead and click trust to allow this. And again, trust is going to allow subsequent operations to generate infrastructure code. Next thing that it's going to do is explain. So explain, similarly as before, it requires the generated code token. So before it explains, in this scenario, we want it to have generated the infrastructure code so it can explain the infrastructure that's going to be created, modified, and it's not just created and modified, right? You could use this to explain existing infrastructure where it'll scan the AWS account, generate the infrastructure representation, and then explain that, right? But this again is using this token-based workflow. So I'm going to trust this explain in case it needs to do it again for the sake of this demo. All right, and it's explaining it. You can see the default tags that are added, and then it's going to be running checkoff, which again uses another token. So this token is the explain token to basically ensure that before checkoff tool is used, it actually explained to you the infrastructure changes that were going to be made. That way you have some validation in there. So I'm going to trust this for running checkoff. This tool takes a little bit longer to run, so we'll give this a little bit of time. Usually takes about like 15 or so seconds, maybe a little bit less. Yeah, about 13 seconds. Okay. And then the next thing that it's going to do, so explain is trusted. So now it's going to explain those security findings. But now, since there's a failure, it's asking us, how do you want us to proceed? So I'm going to just say, keep going. I don't really care about, that rotation just yet for the sake of this demo. But it still pauses and asks us how we want to proceed. So now it's going to proceed with creation. So now it's going to have the create resource, and this is really important. So to create the resource, there's a couple different tokens that it needs. It needs the credentials token, so ensuring that it checked that you have valid AWS credentials and they didn't expire. The explain token, so it's making sure that it actually explained to you what infrastructure is going to be created. The security scanning token, because I have security scanning enabled, and ensuring that it actually ran security scanning before it's attempting to create a resource, so you have validation that the infrastructure change is going to be secure. And then I'm going to go ahead and type, I'm going to do yes for create. Like I mentioned, I recommend for create and update operations, I would do yes. That way you have to approve every subsequent change. But some of these other things like get resource request status, I'm going to do trust. But again, this is also using for a request token. So the request token was generated in this create resource, but I'm going to trust that. Okay, now it says the KMS key was successfully created. The next thing that it's going to do is create the S3, but you can see I didn't do anything. It's continuing on because I trusted these things. So it's checking to get a fresh token, generate environment token, generate infrastructure code. Then it's going to explain the infrastructure that's going to be created, and it's going to talk about the S3 bucket. You see those default tags. Create resource. Again, since I didn't do trust, I'm going to do Y to approve that. And then run Chekhov with the explain token, as you can imagine from before. Actually, that one was trust. Yeah, it just hung a little bit because Chekhov takes a little bit of time. Security scanning, but since I said to keep going, it's basically going to proceed. But again, this is why I said I recommend not trusting modification related resources, because I could then say, hey, actually, what were these two failed check? I mean, it gives you what they are, access logging and versioning, but say if you wanted to actually fix those right then, that's why I recommend not trusting create or update operations. That way you have that second layer of validation. But similarly to as before, these tokens are all going to be there: security scan token, credentials token, and explain token. I'm going to do yes. And then it should continue on to check the request status to see if it created the infrastructure successfully. So we'll give this a little bit of time. All right, so what it's going to do is actually get the request status now. And now you get the summary. So create the KMS key in the S3 bucket. So hopefully that explains the token-based workflow that I was talking about. Like as you see in here, right? It's basically tool A is generating a token, and tool B is requiring that token. So that creates that implicit dependency. And like I said, it's not shown in the diagram or really in this, but these tokens are being validated against something that's called a workflow store in the MCP server, and it's basically in-memory storage. So as the AI agent is trying to fetch and use a token from its context, it's being validated with the actual token that's in the local in-memory storage. Again, this is just very low data, right? These tokens are very short-lived, really just to enforce the order in which the MCP server tools are being called, but it's been very effective. So this is the token-based workflow orchestration new pattern that I designed. So that does it for today's video. Hopefully you got a good understanding of this new pattern for token-based tool orchestration, how it's used in the CCAPI MCP server, and more importantly, how you can use it in your own MCP servers. If you found this video helpful, like, comment, and share, and subscribe if you want to see more content like this. That's all for now. I'll catch you in the next one. Peace.